as somewhere in between Mars and the asteroid belt in our own solar system.
So while we don't have the technology yet to really travel to any of these planets, how long would it take to travel here?
Well, thankfully, we can ask eyes on exoplanets, and if we were able to travel at light speed, we of course could arrive in 39 years. Something more like a jet plane would take far longer, of course, something more on the line of 44 million years.
Wow. Well then, thank you so much, Nicole. Now, Sarah, why are these discoveries so exciting for the scientific community?
Well, with this discovery, we've made a giant accelerated leap forward in the search for habitable worlds and life on other worlds, potentially speaking. Because with not just one planet, but several, we have room that if we didn't have the habitable zone quite right or weren't sure quite what we're looking for, we have many chances over. You could say colloquially, it's like in this planetary system, Goldilocks has many sisters. Now, we don't know much about the planets. We know, as we heard earlier, the masses and sizes and how much radiation is falling on them and their orbits. So for now, we just speculate. And for that, the TRAPPIST-1 system has really captured our imagination, and we have a new travel poster for you that you can download from the NASA website. And if you see here, it's captured scientifically accurately the, how on one of the planets you could see all the other planets in the sky. Now, historically in exoplanets, in the kind of brief history of the last 20 years, when there's one, there's more. And so that's why I'm so excited to be here today to share it with you, because with this amazing system, we know that there must be many more potentially life-bearing worlds out there just waiting to be found.
Thanks. So what are astronomers doing to learn more about this system and others like it?
Well, first of all, Mikkel and his team have started to put up more telescopes. They call it Speculoos, and they're going to, from the ground, use telescopes to search 1,000 of the nearest ultra-cool dwarf stars. And actually, I just have to back up a second about this TRAPPIST system because I forgot to mention that one of the reasons astronomers are so excited about it is it's a veritable laboratory for studying planets orbiting very cool, very small, very dim red stars that are so incredibly different from our sun. In fact, astronomers constantly go back and forth about all the excitement about these worlds because they're very easy to study. Other people have fears and concerns, and so we actually get to test many people's theories about these worlds being tidally locked and radiation from the host star and things like that. So hopefully, we're counting on Speculoos to find more of these systems and planets around these ultra-cool dwarfs, these very common stars that we can study. So in addition to the Speculoos, in astronomy, when someone makes a discovery like this, we put almost any telescope that can follow up. And so in that way, we have, we heard about Hubble already from Nicole, but the Hubble, Kepler K2, Spitzer, and other telescopes are exploring the TRAPPIST system further. I'd say that what the team is most excited about, although this is still a bit in the future, is the James Webb Space Telescope, which will launch later in 2018. Because with this telescope, and the reason the TRAPPIST planets are so significant is that they are accessible to observations with the James Webb Space Telescope. You can see an animation of it here. So with the James Webb, we'll be able to study the atmospheres, and we will try to assess the greenhouse gas content, which will help us understand the surface temperature of the planets. Are they indeed the right temperature to support liquid water and life as we know it? In fact, we're even going to use the James Webb to search for gases that don't belong, that might be produced by life, such as oxygen, ozone, methane, and a whole host of other gases.
Thanks, Sarah. So before we go into Q&A, Thomas, do you have any closing thoughts for us?
You know, for me, this research in exoplanets is really in its gold rush phase. You know, it started something like 20 years ago, and I just couldn't help but notice that the last co-author on your paper is the same co-author who was there at the announcement of the first exoplanet ever discovered and announced in 1995. And since then, we've found thousands of those. A little bit under 5,000 the last time I checked. Dozens of them are in the habitable zone. None until now have had that many planets in the habitable zone. And it's only expanding. This is going forward at a rapid pace, not just because of the telescopes that are there now, but the telescopes we're launching soon. And you talked about the James Webb Telescope, but also TESS, of course, that's going to be there, and WFIRST that's being planned right now. Again, really opening our lens, opening our viewpoints onto the universe, and especially, in many cases, these exoplanets. I do believe that many of the best telescopes that will give us the most information are yet to be invented. There's many things we don't know, many questions we have that come up when we see these observations. We look at all these animations. Very likely, nature is way more beautiful, way more amazing than what we've animated here. It's always that way. And so for us, the question is, how do we actually open up our lens and see these things? How do we get so much data from that the kind of questions that Sarah asked are actually able to be answered? And for me, at the end, it's all about that thought that I have so often when I go to bed at night and really imagine how these other worlds really look like. The fact that there are worlds out there, just like the Earth, that have some commonalities with the Earth, and you could imagine these worlds. It's just only happening right now. These questions about are we alone are being answered as we speak in this decade and the next decades. So I'm really excited about this.
Thanks, Thomas. With that, let's transition to Q&A. We've got a ton of questions on social media, so we'll go there first. If you'd like to ask a question using social media, please use the hashtag AskNASA.
All right, wonderful. We've got lots of questions coming in. This first one comes from Twitter user JJams, who asks, what is the total amount of possibly habitable planets we have found, including these TRAPPIST discoveries?
Okay, I'll take that one. Okay, the total number of habitable planets, believe it or not, is unknown. And it depends on who you ask and how you count them. We would say that there are, let's say, a few dozen exoplanets that you might consider habitable, but the bottom line is that many of them may be a bit too hot or a bit too big. We really have to wait until we can see the atmospheres to know how hot or cold the planets really are. And that's why the TRAPPIST planets are so relevant, because they actually, unlike a lot of the other habitable zone planets, we can actually assess them in the near future.
Wonderful. All right, the next question here comes from Scott, who asks, any confirmation of water on the planetary bodies?
Yeah, I can handle that one. There's has not been any confirmation of water on these planetary bodies, and it'll take a lot of observations with Hubble, or in the future with Webb, to probe the atmospheres and see if we can detect water on these planets.
But I think it's fair to add that people are looking.
Yes, we are certainly looking.
Great. This question comes from Twitter user Matthew, who asks, will this be one of the first observations for JWST? And how much can we learn about TRAPPIST, E, F, and G until that mission launches?
I can take that one too. You know, a lot of folks, since learning about the system, have thought about observing it with JWST, and I am fairly certain that Cycle 1 will see some observations of almost all of the planets in the system.
And then I guess to add further, even now we're continuing to take observations from the ground in Spitzer to look at the transit timing variation. So we're going to get better measurements of the masses of these planets as time goes by. And the next year we'll have much better measurements than we have currently.
Okay, we're going to take one question on the phone line from Jay Bennett from Popular Mechanics, and then we're going to go back to social media. So Jay?
Hello, everyone. I was wondering if the fact that TRAPPIST-1 is a particularly cool red dwarf means that it's more likely to support planets that are potentially habitable because it doesn't have as much stellar activity, solar flares, eruptions, these types of things.
I can take this one. So ultra-cool dwarfs are known to be very active when they are young, and this is the main concern about these potentially habitable planets, that they could have been, the atmosphere been eroded strongly by the star when it was young. Now it's a quite ultra-cool dwarf, so it's not very active. But maybe when it was young, the conditions were quite different. So it will be by observation that we will really figure out the paths of these planets and what happened during this very active and young phase.
I'll just add to that and rephrase what Mikhail said to just say the great news is we can observe in the near future. We no longer have to rely on what we think and speculation, because nature usually is smarter than we are. And if there's any way for a life to get a foothold, we like to believe it will.
Thank you. We're going to go back to social media. So, Jason?
All right, this question comes from Twitter user Amara, who asks, have you decided any names for these planets yet?
Cheers.
Yeah, definitely.
A name. To give them a name.
Will they wing like a popular name? Like,
Oh, well, we have plenty of possibilities which are all related to Belgian beers, but we don't think they will become official, so
right.
for now, let's call them B, C, D, and so on.
Admittedly, we have no way to easily give official names to exoplanets in the same way that we do for asteroids, but perhaps it's something we should try to change.
Great. This next question comes from Twitter user Joe Fiend, who asks, does the Earth-sized planets have any moons revolving around them? And if no, how can there be possible waves on water?
Well, in our data, we have no indication of a moon. And so, furthermore, if we look at our theory, it would be quite unlikely to have a moon around a planet so close to its star. So maybe if there are outer planets still to found, maybe they could have a moon. We'll see in the future. There are still many news to come about the system.
But I'll add further, the tidal forces between the planets are not negligible, so if there was water on these planets, there would be tides as well, because of the tidal forces between the planets instead of planet-moon.
Yes, indeed.
Next, we're going to go to the phone lines. We have Keith Cowing from NASA Watch. Keith?
Hi, a question probably best for Sarah Seeger. I'm looking at these planets. I assume they're really close together. It reminds me of the Jovian and the Saturnian systems where stuff is thrown from one world onto another, and there's questions about why, should you consider these as an ecosystem? I'm a biologist. I'm looking at 3 potentially habitable worlds real close to each other. Should we be thinking that conceivably the biosphere around this very tight-knit group of planets might extend beyond just one planet if they're this close to each other?
Well, that's a wonderful question, and we haven't thought that far yet. But I'm sure there's a student out there, listening in who should take this problem on. I'll just back up one step, though, and answer a slightly different question, because if we want to think about an intelligent civilization elsewhere looking back at us, they may be having a press conference saying, hey, there's 3 habitable planets there. Venus, Earth, and Mars may appear to be in the habitable zone no matter how we describe it. So let's wait and see what's out there. But great question, and hopefully somebody will work on this.
Next on the phone lines, we have Marcia Dunn from Associated Press.
Yes, hello. I was wondering, how many years do you think it might take to have a real good handle on the atmospheres of these exoplanets? And I have a follow-up question.
Yeah, so we could actually make a substantial amount of progress in the next, after the launch of JWST, the next sort of 5 years range. So starting with Hubble and then moving into JWST to continue the exploration of these atmospheres, we could see results, in the early 2020s.
And thank you. And I know this is the first time 7 Earth-sized planets have appeared around a star like this. What is the closest runner-up to that? How many Earth-sized planets around a star that you've seen prior?
3. I think it's a 2 or 3.
Yeah.
No more, found by Kepler.
And which star is that?
Oh, I don't remember. There are so many Kepler planets.
Okay, thank you.
So, let's go back to social media. Jason?
All right, this question comes from Miles O'Brien here on Twitter, who asks, what sort of instrument could be used to answer the question of whether these planets harbor life? Could Webb do it?
Sure. So Webb has a suite of instruments that cover, wavelengths from sort of the near infrared all the way through farther into the infrared spectrum. And then in particular, it has a lot of very powerful spectrographs aboard. So this is going to allow us to do this transmission spectroscopy technique that I talked about earlier. And it covers the right wavelength range where we can start to detect molecules like water, methane, ozone, and oxygen. So we can start to do a lot of what Sarah had suggested in trying to determine habitability and also the potential of it harboring life.
And I just want to add one thing, and to Miles and everyone out there, is we really try to emphasize we have the capability to find signs of life elsewhere, but nature has to deliver. And because it's also new to us, these red dwarf stars, we don't totally know what's out there. So if nature has made life ubiquitous, and there are lots of atmospheres without clouds, substantial enough accumulation of gases, we'll have no trouble finding it at all. But if it's the opposite, then it may be a while. But I did want to add one more point that we hadn't covered yet, that we have the TESS mission upcoming, we have other ground-based searches, so TRAPPIST-1, we're just here as the first, it's the most exciting one so far, but we hope to have many more of these, and lots of chances to find signs of life in the future.